We're going to start this study of elementary statistics with chapters 1 and 2 this week. And as far as objectives are concerned, they're listed at the beginning of each of the chapters in your textbook. So the chapter 1 objectives are basically dealing with vocabulary, all the different things that we need to know, terminology that we're working with as we're studying statistics. Chapter 2 deals with how to organize our data into distributions and then graph those distributions. So let's start. To begin with, statistics is the science of conducting studies to collect, organize, summarize, analyze, and draw conclusions from data. Well, the first three words that are listed in that definition there, collect, organize, and summarize, fall into the category of descriptive statistics, whereas the last two terms, analyze and draw conclusions, deal with inferential statistics. Now, what that means is the majority of our class, probably 70%, we're going to spend on descriptive statistics, getting our data together, summarizing, making presentations, that sort of thing. But the meat of the course is in inferential statistics, where you can generalize attributes of a population based on information that you gather from samples. Maybe even make predictions. So we're going to get into that as well, but to begin with, we're going to look at descriptive statistics. A good example of these two terms can be found in your textbook on page 4. So if you'll turn to page 4, example 1-1, the first part, part A, reads the average price of a 30-second ad for the Academy Awards show in a recent year was $1.90 million. And you're asked to decide, is that descriptive or inferential? Now, the reason that's descriptive is because this is based on actual data that was collected in a recent year. Whereas when you look at question B on that same problem, the Department of Economic and Social Affairs predicts that the population of Mexico City, Mexico, in 2030 will be 238,647,000 people. This is inferential, and the reason it's inferential is because it's being used to make a prediction. Now, we also need to know some vocabulary when we're talking about data collection and such. So 4 terms that come up quite a bit are these: variable, data, population, and sample. A variable, this term is a little different than the word variable that was used in algebra. It's describing a characteristic or attribute that can assume different values. So really, when we look at it in terms of statistics, we're talking about a variable of interest. What is our study about? What are we researching? What is our variable of interest? For example, suppose we were concerned about pollution affecting the size of the fish in Tar River. Then our variable of interest would be concerning the size of the fish in Tar River. So, and to determine that, we would develop some type of study. And when we do that, we're going to get some values. We're going to, gather some information, and that information about the variable of interest is called data. Well, we can't drain the river and study the size of all the fish. All the fish in the river would be the population, all the subjects that are under study. However, what we could do is gather some samples, like a catch and release, catch and measure the size, then release and catch another sample, that sort of thing. For our population. So we need to be aware of these 4 terms. Now, this information that we gather may be numerical or it might be categorical. So if it is categorical, we call that qualitative data. If it is numerical, numbers, then that's quantitative. So you want to keep those two straight as well. And things that would be considered qualitative data would be things like gender. you answer surveys all the time, and one of the first things they want to know, male or female. So that is a qualitative value. Other things like eye color, let's see what else. Geographic location, like what part of the country are you from? Okay, notice that those are all word type answers. Quantitative, though, is going to be numerical, and it is subdivided into two branches here as well, and that is discrete and continuous. And with discrete, that means that it is countable, that whatever the data that you get is you receive that by doing a count, not a measure, whereas continuous is measurable. Either you weighed it or found its length, height, that kind of thing. So for examples for discrete would be things like the number of desks in a room, number of desks, or something like number of students on the roster. Kind of giving you a little hint here with the word number of something. Whereas continuous would be numerical measures, data values that you get by measuring. So anything that's measurable, temperature, weight, height, length, any of those types of measures. Now, when you do measure, we usually round off our measurements. Like, for example, if a student were to measure 5'3", that's 63 inches, they're probably not measuring exactly 63 inches. You know, their measurement could be anywhere from like 62.5. Would you agree with me that if they measured 62.5, that we would round that up, the nearest whole number would be 63? That 62.5 does not round back down to 62. So if they measured 62.5, then, and I rounded that measure, it would round up to 63. Or if I measured 62.6, or 62.7, or 62.8, as we keep on climbing up our scale here, till we get to 63. Any of these measures here would round to the whole number 63. Even beyond that, like 63.1, 63.2, 63.3, until we get to what number? You're right, 63.5. Now 63.5 is going to round up to 64. So we're not going to include that. That's like open circle. I don't know if you can tell that on the picture there. We're not including the 63.5, but we do include all of these this infinite list of numbers from 62.5 up to, but not including 63.5. So what we say in this case is that 63 inches has the boundaries, and the boundaries for 63 inches is 62.5 to 63.5. Now, you might be looking at that and say, well, we just said we don't include the 63.5. Well, statisticians have agreed on this, that when you list the boundaries for a measurement, the right-hand endpoint in your boundary is not included. So you might want to make yourself a little note that that does not include the right-hand endpoint. Right-hand endpoint. But you do include the left-hand endpoint. Okay. So here I've got several measures on the slide. And we're looking at measures that were recorded, everything from 15 centimeters of length, and then the appropriate boundaries for that, the temperature, 86 degrees Fahrenheit, and its boundaries. And then we have this time of 0.43 seconds and its boundaries, and the mass, 1.6 grams. Now, if you have trouble understanding where those boundaries are coming from, there's a little technique that I've shown students in the past that's been helpful for some. If we considered the 15, we can annex that with 0.0. Excuse me, let me bring that down some. Put a 0.0 on the end of that. And that's the same number. 15.0 is the same thing as 15. And just looking at these last two digits here, ask ourselves the question, don't think about the decimal point or anything, just think about the number 50. 50 lies between what two numbers that end in 5? Well, it lies between 45 and 55. And then go back and put in your decimal point and other digits, like bring down your 1 in front of both of those, and then your decimal point. So this is the boundaries, 14.5 to 15.5. That little technique will work if you want to try to use that if you're having trouble. So like the 86, we can think of that as 86. Annex that with a 0. Consider just the last two digits, 60. So 60 lies between what two digits, or what two numbers that end in 5, excuse me. That would be 55 and 65. And then go back and fill in everything else, 8 and our decimal point. So that's our boundaries. Even when it comes to something like the 0.43 seconds, we can do the same thing with this. Annex that with a 0. That means at the end of that number, we're going to add on a 0. Looking at the last two digits, just this, the 30. 30 lies between what two numbers that end in 5, and that's going to be 25 and 35. And then go back and fill in everything else. So we've got 0.4, 0.4. So this is our boundaries. And then for the last one, the mass, we've got 1.6. Annex that with a 0. Looking at the last two digits, 60 lies between what two numbers that end in 5? And that is 55 and 65. And then go back and fill in the rest. And now we have our boundaries for that one as well. So this little technique might help you to decide on what the boundaries would be for a measured value that's been rounded. Okay, and we'll pick up with the next part on the next video.